Okay, so hi everyone. My name is Luke Carty, and I'm a security solutions architect in the professional services team at GitHub. Day to day, I work with our customers to help them deploy and use the cool security features in our products. And one of my favorite parts of the job is teaching people how to write CodeQL. So I'm genuinely really excited to be presenting today's session on finding security vulnerabilities in Java with CodeQL. So today what we're going to cover is what CodeQL is, how to use CodeQL to identify patterns in source code, and then we will provide a hands-on session where we'll guide you through the process of writing a query to find a known security vulnerability in Apache structs. So we're going to start off with a short slide deck here, about 15 minutes, and then we'll move into the hands-on session. The session is designed for total beginners, so don't feel like you need any existing experience of CodeQL. And also, although this session is focused on analyzing a Java project, you also don't need extensive experience of Java either. And the CodeQL skills that you learn today will actually be transferable to analyzing other languages with CodeQL. Now, if you want to follow along with the hands-on session, you will need to set up the CodeQL development environment. The link is on the screen here to the repository containing the prerequisites. I think that's been shared with you already. But if you haven't set this up now, now would be a good time to start. We also have a Slack channel where you can ask questions, and we have a few helpers on the call here who are also on the Slack channel. So we have Anders, Arthur, and Aditya, and they'll be answering questions on the channel itself, and also be checking in with them periodically to see if there are answers that we want to share with the whole group. Okay, so what is CodeQL? So the key idea behind CodeQL is analyzing code as data. What we do is we create a database of facts about your program, then provide an expressive declarative query language called QL for identifying patterns in that database. So what can I do with it? Well, the main use case is to find bugs and security vulnerabilities in your code. Developers are human, and unfortunately humans make mistakes. Not only that, but they make the same types of mistake over and over again. What CodeQL provides is a way to describe and automatically search for the patterns underlying those mistakes. The CodeQL query language is very high level and it's very expressive, which makes it very quick and easy to write or refine queries and to provide really accurate results. So what this allows us to do is to help automate repetitive security code review by taking the expertise of security researchers and allowing them to express their knowledge in this sort of codified, readable, executable form in these queries. So some might ask, why a new language? Aren't there already enough languages in the world? Well, CodeQL has a fairly unique combination of features, which makes it ideally suited to writing queries for analyzing code. So first, it is a logic programming language. What this means is that you specify logical conditions that describe the patterns you want to find. These conditions are combined with operators such as and, not, and or. Second, it is declarative, which means that the order in which you specify the conditions does not matter, and that there are no side effects. Now, together, these features mean you can focus on describing what you want to find, not how you want to find it. Instead, what we do is we provide an advanced query optimizer which takes the high-level declarative CodeQL query and automatically compiles it to an efficiently executed form. Now, thirdly, QL is object-oriented, and this may seem very strange for a query language. We'll explain exactly what this looks like in more detail in a few slides' time, but the benefit here is the same as other object-oriented languages. So we can encapsulate data and operations on that data together. We can benefit from inheritance, composition, and other object-oriented type patterns. This also allows us to provide very rich standard libraries that include comprehensive representation of the program, but also simple to use libraries for performing common program analysis tasks, so data flow analysis, control flow analysis, range analysis. Finally, we should also mention that CodeQL is a read-only query language. There are no options for inserting new rows into the database. Instead, the database is built in a single step from a particular checkout of the source code. So, what does a query actually look like? Well, the basic syntax of QL will look familiar to anyone who's used SQL or similar query languages. There's a query clause. And this query clause is made up of three parts: a from part, a where part, and a select part. So from, where, and select. And here, the from clause specifies some variables that will be used in the query. The where clause specifies some conditions on those variables in the form of logical formula. And the select clause specifies what the result should be and can refer to variables that were defined in the from clause. There's also a series of imports at the top of the query, which lets us reuse logic defined in other libraries. So this import Java allows us to import the standard library for Java. Let's take a closer look at this example and see if we can figure out what it's doing. So the from clause is defined as a series of variable declarations, where each declaration has a type and a name. For example, this declaration here is for a variable called if statement, and it has a type if statement, which is from the CodeQL standard library for Java, which we imported above. Types represent sets of values. So for example, this if statement type here represents the set of all if statements in the program. Variables also represent set of values, initially constrained by the type of the variable. So this variable here initially represents the set of all if statements in the program. And what we'll do is we will later refine that with the conditions that we apply. Similarly, the second variable here, block, represents the set of all blocks in the program, i.e. elements surrounded by curly braces, typically a sequence of statements. Now the where clause allows us to specify some conditions on these variables and combine these with logical operators such as AND. Here we provide a condition that specifies the block variable is equal to the if statement .getThen. There are two important aspects here. So firstly, the if statement .getThen. This shows the object-oriented nature of CodeQL. So getThen, this is an operation that is provided on the type if statement, and it returns the then part of an if statement. So if you think of what an if looks like, typically it's a if some condition, then something happens, else something else happens. So when we say getThen, it's the thing that happens if the condition is true. So this is demonstrating the object-oriented nature of CodeQL. Now the second aspect here that's important is that this equals here is equality, not assignment. We are not assigning this value into the variable block. We are saying that it is equal to this if statement .getThen. This is specifying a logical condition. Essentially it's saying, find me all pairs of blocks and if statements in the program where the block equals the then part of the if statement. Now we can see that the where clause also has a second condition here that we combined with AND, meaning that both conditions must be true. And the second condition says block.getNum statement equals 0. Again, we can read this in a sort of natural language way where we say this says, find me all blocks in the program whose number of statements is 0. In other words, empty blocks. So if we step back a bit here, we can see that this query is actually finding if statements which have an empty then block. Now finally, if we have a look at the last part of the query here, the select clause, this is actually what defines the result of the query. And here what we can see is we select an element in the program and a message that we're going to report at this for this element in the program. And this is how we report static analysis issues in your code base. It's a location in the code base and a message at that location. Now, one way to think of the select is that it's going to produce effectively a table of results, where the first column is if statements and the second column is the message associated with those if statements. So what we're going to do now is take a brief tour through some of the reuse and encapsulation features in CodeQL before we actually start the hands-on session. So these are the building blocks of queries. So the first feature that we'll introduce you to is predicates. So these provide a way to encapsulate portions of logic in the program so that they can be reused. You can think of them as a mini from-where select. Like a select clause, they effectively produce a set of rows in a result table. The difference here is that you can name the table of results and you can reuse them. So here's an example. So we have the query that we had on the previous page. And what we might want to do is write multiple queries that need to identify empty blocks in the program. We can do this by introducing a predicate which identifies the set of empty blocks. This is done by using the predicate keyword, then providing a name for our predicate so that we can reuse it, and then a series of variable declarations that's similar to the from part of a from where select. Now the body of the predicate, the bit inside here, is effectively equivalent to the where clause that we had before. So here what we can say is that is empty. So it takes a single variable declaration block, and what it's going to do is it's going to represent the set of all blocks in the program which are empty. Now, how do we define that? Well, we need to put this condition in the body of the predicate. And this condition is the same condition that we had before. We know that this condition defines what it means to be an empty block. We're now just giving this a name. So this predicate will represent the set of blocks in the program that are considered to be empty. We can then use this predicate to simplify our query by using it as a logical condition in the where clause to say that the then part of the if statement must be empty. So you can think of this in one of two ways. You can think of this as the logical conditions induced here are effectively inlined. So you can think of this in a logical way, or you can think of this in a sort of set way. You can think, well, let's take the set of all if statements and let's filter it by the ones which are where the blocks are empty. And if we look at this query, well, the same logical conditions are being applied on both sides, and we'll get the same set of results for both. So the next feature that we'll look at today is classes. So classes allow you to define new types in CodeQL, and like all types, they describe sets of values. So we've already seen two classes in CodeQL, block and if statement, and those are defined in the standard libraries. For example, we could define a new CodeQL class to represent the set of empty blocks. The way that we define this, so we use the keyword class, we provide a name for our class, in this case empty block, and then we provide a set of supertypes, in this case block. All classes in QL must have at least one supertype, and the supertypes define the initial set of values in our class. In our case, empty block starts with all the values in the block class. However, a class that can only represent the same values, set of values as another class is not particularly interesting. We can therefore provide what we call a characteristic predicate, which is this thing here. This looks a little bit like a constructor. Don't get deceived, it isn't really. But effectively what it allows you to do is to define some additional conditions that can restrict the set of values further. So in this case, what we're saying is we start off with a set of all blocks in the program. And what it means for a block to be an empty block is, well, it's the same condition that we had before, that the number of statements in that block equals 0. And you notice within here, we can use this magic variable called this. This refers to the block that we're starting with and allows us to define logical conditions on the instance here of the class that we're using. Note that a value can belong to more than one of these sets of values, which means it can have more than one type. As a simple example here, empty blocks are clearly both blocks and empty blocks. Now, so far, this class is actually equivalent to the predicate solution that we saw previously. We're in fact supplying the same set of conditions, and we will calculate the same set of values as with the predicate case. In both cases, we're calculating a table effectively that says here are all the empty blocks in the program. The difference is actually how we use it. So one way in which we can use it is to say if statement.get then instance of empty block. This is a logical condition that says we only want those if statements whose then part is within the set of empty blocks. Now we can actually use this another way. So the other way that we can use this is by defining a variable, a temporary variable here. And this temporary variable, we can specify the type directly as empty block. Now, when we apply this logical condition here, we're only starting with a set of empty blocks to begin with. So we're only going to match this logical condition against the empty blocks. So again, this is equivalent to the two previous queries that we've seen. Okay, I've done more than enough talking now. So let's move on to the hands-on part of the workshop. If you haven't already done so, please follow the link on the slide and get VS Code and the CodeQL extensions set up. If you have any questions, then please do ask on the Slack channel. As I said, Anders, Aditya, and Arthur are all there to help answer your questions. Arthur, do we have any interesting questions on the Slack channel that we want to bring up?
There was one question about whether the workshops would be recorded and sent out to the audience for later viewing.
I believe they are being recorded. I think they're also being shared later as well.
Great, thanks for confirming.
Cool, all right, thanks. Okay, so let's switch over from the slide deck. So, okay, so what I have here is my VS Code window. I've got that markdown document here that's referred to in the repository. You can find it there as well. I'll be following along as we go through here, so you don't necessarily need to have it open yourself, although you might find it helpful as we go through. Okay, let's get started. All right, so this workshop is on finding an unsafe deserialization issue in Apache struts. So serialization is the process of converting in-memory objects to text or binary output formats, usually for the purpose of sharing or saving program state. The serialized data can then be loaded back into memory at a future point through the process of deserialization. So in languages such as Java, Python, Ruby, C#, deserialization provides the ability to restore not only the primitive data, but also complex types such as library and user-defined classes. So this provides great power and flexibility, but does also introduce a significant attack vector if the deserialization happens on untrusted user data without restriction. So I'm sure you're all familiar with Apache Struts. It's a popular open source MVC framework for creating web applications in Java. Now in 2017, a researcher from the predecessor of the GitHub Security Lab found a CVE 2017-9825, which was an XML deserialization vulnerability in Apache Struts. And it was severe enough that it would allow remote code execution. Now the problem occurred because included as part of the Apache Struts framework is the ability to accept requests in multiple different formats or content types. And Apache Struts actually provides a pluggable system for doing this through this content type handler interface. And that interface provides an interface method to object. So you can define a new content type handler for, say, XML or JSON by implementing this interface and defining your own toObject method, which takes data in the first parameter in the form of a reader, and uses that to populate the target object, which is taken as the second parameter. Now, typically this reader, this input is provided directly from the user without any sort of validation, so it can't really be trusted. And typically, the way a content handler works is it's going to take this reader and it's effectively going to deserialize the contents to populate the target object. Now, this shouldn't happen without any kind of validation, because if it happens without any kind of validation, then the untrusted user data could be deserialized in a fairly arbitrary way. And this is what caused this particular CVE. So what we're going to do in this workshop is we're going to write a query to find the CVE in a database that's specifically built from the known vulnerable version of Apache Struts. Okay, so as I said before, if you haven't already, please follow the setup instructions for Visual Studio Code. So you'll need to install the Visual Studio Code IDE, and then install the CodeQL extension for Visual Studio Code. You can install it from the extension panel here. You also need to set up the starter workspace. And the reason for this is the starter workspace has links to the standard libraries. So if you don't set up the starter workspace, you don't get the standard libraries and you aren't able to easily write queries. Once you have the starter workspace, you'll need to open that within VS Code. You will also need to download and unzip the vulnerable database, and you'll need to choose this database in CodeQL using the Control-Shift-P to open the command palette and selecting CodeQL Choose Database. And then what you need to do is to create a new file in the CodeQL custom queries Java directory called unsafe deserialization. So you can see that's what I've done here. I've got this unsafe deserialization QL file, and I've got this open underneath here. If you get stuck through this, or if you want to look up more documentation later on, there's actually extensive public documentation on how to write CodeQL. So there's a general landing page for learning CodeQL. There's one specifically for Java, and there's a lot of public documentation as well about using the CodeQL extension for VS Code. Okay, so the way this workshop is going to work is that it's split into several steps. And so it's up to you. You can either write one query per step, or you can kind of write a single query that you refine at each step. I'm going to go for the approach of writing a single query. Each step, each question has a hint associated with it. And that hint describes some useful classes and predicates in the standard libraries for Java. So you can explore these in your IDE using the autocomplete suggestions and also the jump to definition command. What I'm going to do is, after reading out each of these questions, I'm going to pause and give you the opportunity to answer it for yourself, and leave a gap of around 2 minutes for these first ones and maybe a little bit longer for some of the later ones. What I'll do is I'll actually start a timer in VS Code. So a timer start, 2 minutes, and at the bottom here it will give us a timer to work on, just so we keep to time. Don't worry if you get left behind. We're going to build in a couple of pauses to answer questions and things. And if it's going too fast or too slow, you can ask questions on the Slack channel at the same time. Before we get started, I'm just going to show you a couple of features of kind of how to actually use VS Code to write CodeQL. So you can see we've got this unsafe deserialization query file here. We've added the import in at the top for the standard library. What I'll do is I'll just write a simple query here. So let's write a query just to find all the if statements in the program. So you can see here we get autocomplete. We can hit enter there to write the from. We can hit control space here to bring up the autocomplete as well. So you can see here it's giving us type suggestions, because the first thing we need to do is define a CodeQL type. So if statement, here we can see that it's provided us with the if statement type as an option. We can hit enter. We can provide a name for this if statement, and we can provide a select saying if statement. Again, you can see it's auto-completed that. And we can save that file. You'll note here you can actually write from where selects without the where. In fact, only the select is mandatory here. Right, now we can run this query. So there are two ways that we could run this query. One is to right-click in this file here and click CodeQL Run Query. The other way, which I typically use, is to open the command palette. Again, that's Control-Shift-P in VS Code, and choose the Run Query option here. So we can run this query, and you see we get the results back on this right-hand side. And the results are numbered, and the ones that are elements in the program, that are locations in the program, these are actually clickable links. So if I click on this first one, you can see it takes us to the read-only copy of the Apache Struct source code for the line at which this program element exists. So we can see here, this was all the if statements in the program. There are 8,500 of them. And if we click on them, it will take us to the line where each one of these is defined. So that's how you browse through the results. Okay, so section 1. So finding XML deserialization. So Xstream is a Java framework which is used for serializing and deserializing Java objects to and from XML. And it's used by Apache Structs. And what it does is it provides a method called fromXML, which is used for deserializing XML to a Java object. Now, by default, the input is not validated in any way. So Xstream does come with some validation features, but they are not on by default. And so it is vulnerable to remote code execution exploits. So in this section, what we'll do is we'll identify some calls to fromXML in the code base. Okay, so question 1 here is to find all method calls in the program. What I'll do is I'll just start a timer here and give you a couple of minutes to test that out. Remember, if you get stuck, do ask questions on the Slack channel. Remember, there's also a hint here, so if you have the Markdown document open yourself, you can press this button here and it will show you a hint.
Hey, Luke, this is Jason jumping in. It seems like we might have lost audio. If you can hear me, just letting you know.
Can you hear me now?
Yeah, loud and clear.
Okay, did you miss the question on that previous part?
We did. Let's go ahead and repeat that.
Okay, let's repeat the question then, sorry. Question 2 here is to update your query to report the method being called by each method call. So I'll restart the timer here. Okay, let's go through the answer to question 2. So we have the query from method access call, and the question is to update the query to report the method being called by each method call. And if we expand out the hints here, the suggestions are to add a CodeQL variable called method with the type method. That method access has a predicate called getMethod for returning the method. And then the final suggestion here is to add a where clause. So what we're going to do is, as it suggests, we're going to add a new variable whose type is method and whose name we're going to call method. We're then going to add a where clause, and in the where clause, we're going to say call.getMethod equals method. And then we're going to report that as part of the select clause. I'm going to run this query. So this is similar to the if statement and empty block query. Again, we have two variables here, and we're just relating them with a logical condition. So we're saying, find all pairs of method accesses and methods in the program where the method being called by the method access is this method variable. And we're just reporting all of these. Now what we can see is we actually have 2 columns of results here, where the first column is the method call. So this is the method call I looked at before. And the second column here is the method being called. So we can see the relationship between these two. And if we look up above, then again, we have about 68,000 results. Okay, so question 3. Find all calls in the program to methods called from XML. And you can update this query here just to add that additional condition. Okay, we'll go through the answer to question 3. So if we expand out the hint here, see the hint says method.getName returns a string representing the name of the method. So the way that we're going to do this is we're going to add a second condition into the query, where we say that the method that we've identified as the target of this call, getName of the method, equals from XML. So you can think of this as applying an additional logical condition here, saying only report me the methods whose name is from XML. Let's run this query. And we can see we now only get 2 results. So remember from when we started at the top, we had 68,000 results. Well, actually only 2 of them are to the from XML method. And again, we can click in here and look what they look like. All right, question 4. The extreme.fromXML method deserializes the first argument, i.e. the argument at index 0. Update your query to report the deserialized argument. Actually, sorry, before we start that, there was one optimization we can actually do for this particular query here. So in general for this query, we're not actually going to need the method itself. The thing we'll be interested in is the call. So we could actually just remove the method from the select clause here. Now, if we remove this method, then actually the only thing that we're reporting here is the call and not this method variable. And actually, if we have a look at what we're doing here, we could actually inline this. So the way that we can inline this is by deleting this method variable and then inlining this condition. So logically, this is exactly the same, apart from the fact that it's only reporting the call. But again, you can read this as we read the other logical conditions as saying for a method call, get me the method, get the name of that method, and assert that it's called from XML. So this is just a simplification of this query. And if we run it again, we can see we still get the same 2 results here. Okay, so question 4 again. The extreme.fromXML method deserializes the first argument, i.e. the argument at index 0. So let's update this query to report the deserialized argument. And do let us know in the Slack channel if the timings here are too long or too short. You want a bit more time, a bit less time. We can tweak this as we go through. Okay, let's go through the answer then. So the hint here is that method call.getArguments, int I, returns the argument at the ith index. And the arguments are expressions in the program, which are represented by the CodeQL class expression, or expr. So the assertion here is to introduce a new variable to hold the argument expression. So we can do that by saying expr arg. We can add an additional condition here that ties together the arg and the method call. So what we're going to say is that the arg is equal to call get argument 0, because the argument that's deserialized is at index 0. It's the first argument to the call. We can update the select here. and rerun this query. And you can see that we now have the same two results that we had before. So we now have two columns. So the first column selects the from XML, and the second column selects the thing that's being deserialized. So in particular here. Okay, so final question in this section. Recall from the presentation that that predicates allow you to encapsulate logical conditions in a reusable format. So this question is about converting your previous query into a predicate which identifies the set of expressions in the program which are deserialized directly by from XML. And so we've got a template here that you can follow. And this actually introduces a new concept in CodeQL, which is this exists. So you can think of an exists as a mechanism effectively for introducing temporary variables with a restricted scope. And again, a bit like predicates themselves, you can think of them as their own mini from where select. So you have a series of variable declarations at the top here, and then some conditions in the body that must hold. And we're using this exists here because we actually don't care about the method access itself outside this predicate. Actually, what we want to get out of it is the argument that is going to be deserialized. Okay, so again, the question is convert your previous query into a predicate of this form. Okay, so I'll go through the answer here. So let's start off by copying the template that we provided above. And what we're essentially going to do is take the contents of the where clause that we wrote before, and then we're going to put them in the body of this exist, because the conditions that we want to apply here are effectively the same. We'll need to do a little bit of renaming because we previously called the method access call. Actually, now we're going to call it from XML. And so from a set point of view, the way to think about this is that we now have a predicate that names a table of results that represent the set of all expressions in the program that we think are directly deserialized as XML or from XML. Now what we're going to do is to update the query itself so we can actually use this. So we now only need the expression. I'm going to change it so that, like with the example that we saw on the slide deck, we're going to refer to this predicate here. Just report the argument. If we rerun this query, you can see that we get the 2 results, and again, these are the same 2 results that we've been following through for the last 3 steps. Okay, so that's the end of section 1. So I'm going to ask Arthur now if there are any questions on the Slack channel, any feedback on timings, whether we want a little bit longer, a little bit slower. Yeah, Arthur, over to you.
Let me unmute first. There's one question that just came in. What's the difference between using expr or argument in the from in this case?
The difference between expr and arg in the from. So in this from clause, the expr is the type of the variable, and arg is the name of the variable. Is that the question? What the difference between those 2 aspects is?
Yes, or maybe it's about using get argument. It might be to confuse me the type and a method name. I'm not really sure.
Okay.
Is there an argument type actually?
Is there an argument type? Oh, I see. Okay, I understand. Yeah. So actually, if we have a look at these predicates here, if we mouse over them, we actually get some context-specific help about what this actually does. So you can see the get argument predicate here gets the argument, the specified 0-based position in this method access. And you can also see that it has a signature here that helps us understand what parameters it itself takes and what it might return. And so you can see in this case, the get argument actually returns something of type expression. And so that's because in the model of the program, so if we think about what's actually stored in our database, it's effectively a model of the program in a sort of tree structure known as abstract syntax tree, an AST. And in that tree structure, the tree structure represents the sort of hierarchical nesting of the program. And so if we think about what a method call looks like this one, so this is going to be represented as a method access in the database, and it's going to have children in this tree, in this AST tree, for the qualifier of the call and for each of the arguments of the call. And those arguments here can actually be any type of expression in the program. So in this sense, it doesn't make sense to have a specific QL type for argument. Because it doesn't, because this can be any type of expression. So we may as well use the same QL class that we have defined for that. So hopefully that answers that particular question. Yeah, is there any feedback on timings or anything?
Not at the moment. Someone is asking if there's human readable documentation outside of Visual Studio available for all the predicates and libraries.
Yeah, so we have a help site, help.seml.com. In fact, I think it's referred to at the end of the Markdown document. Yeah, and then there's documentation. And in fact, if we scroll back up to the top here, the documentation links, learning CodeQL for Java, I think that has links to the standard library for Java. So you can see all this QL documentation. So the stuff that comes up on the overlay here, that's all published to the public help site. And the Learning CodeQL for Java also has tutorials for using different aspects of the standard library, so data flow or using the AST nodes. So you should be able to find everything that you need there, as well as in VS Code.
Yeah, another question about the pipe symbols in the exists statement. So I think the question is, why can there be 2? Like you can say why exists and then a condition and then another condition separated with a bar?
Yeah, okay. So I think the question is that you could do something like that, right? You're allowed to do that. Is that the question?
Yes, I think so. Is this like, yeah, if there's, why does it exist and what's the difference, if any, and what's preferred?
Yeah, so well, let's start off with the kind of exists. So exists is a special kind of a component in QL called a quantifier. It's actually an existential quantifier. So if you've done any logic, formal logic before, you'll kind of recognize this this terminology. And the structure of this exists is that it has a series of variable declarations and then some conditions within the exists. And so typically in the simple case, you'll just see us using the standard logical conditions to combine the formula that we need to specify for the body of the exists. Now, there's also a two-part version of this, and the reason there exists a two-part version of this is because there are other quantifiers. So in particular, there's a quantifier called for all, which talks about, again, if you've done any formal logic, this terminology will be recognizable, which talks about having a series of declarations, a range for those declarations, and something that has to be true for all of them. Now in this case that doesn't particularly make sense, but the exists syntax that uses a bar is there because the for all syntax requires the bar. And in actual fact, for exists, this is entirely equivalent because the way I just described it, with the two bars here, we have a range and something that needs to be true for at least one thing in the range. Well, if you think about that a little bit, well, that's actually just the same as combining these two conditions with and. Now, one area where it can be a little bit helpful to use this is if you have something like this, where you might say arg.from xml.get argument 0, maybe say that the first argument could also be deserialized as well. Well, then you could write it like this, but you can see we've had to put brackets here because the or, because of the precedence of and or. So we've got to be clear about kind of which ones grouped together. And so you'll sometimes see in QL the use of a bar here to avoid that, because the bar avoids the precedence question. So I hope that answers the question.
Yes, I think it does. Thank you.
Is there anything else?
There was one advanced question. I was actually asked quite a lot of answers already, but about whether CodeQL queries can be run on the output of binary tools such as LLVM, so other things than source code.
So I think there's two answers to that question. So, I mean, if you think about the fundamental process that we're doing here, which is building a database of facts and then writing queries on that database of facts, then there's no theoretical reason why you couldn't do this also on binaries, right? There's no kind of limitation there. So that's the kind of theoretical question. The practical question is that we don't support at the moment analyzing binaries. The only type of binary support that we do have is for C#. And for C# we can analyze DLLs, assemblies that are written in .NET bytecode. So it's called CIL. Now, one of the reasons that we don't support this is because it can be tricky to. So, firstly, I mean, sort of the main purpose for what we do is static analysis of source code, and so it hasn't necessarily been our focus to look at binary analysis, because it's a sort of different area and a different topic and often different use cases. And one of the challenges with binary analysis is. So in particular, what we usually focus on is trying to report results to developers so that they can actually fix them. And if you do a binary analysis, then it's tricky to then correlate that back to some source code that you can actually report an issue on. And so that's one reason why, from a pragmatic point of view, we haven't really looked at it. Now, the C# case is actually quite interesting, because what we do for C# is we analyze the assemblies that your source code depends on. So when you do a build of a C# project, typically when you're doing the compilation, you depend on some DLLs, some assemblies, and we actually analyze the assemblies and put the bytecode, a database representation of the bytecode in the database, alongside the database representation of your source code. And then what we do is we use that to analyze data flow through your libraries as well as your source code. And so that's one area where the sort of binary analysis or bytecode analysis can be really useful for source code analysis. Now, as I say, that's something that we have for C# at the moment. We don't have it for other languages. Java is one where we could potentially take the same approach. And I think that's definitely an area of interest, but it's not one that we've got planned right now. But that's a good question. Thanks. Any other questions?
I don't think so. Thank you, Luke.
All right, great. Okay, hopefully everyone's ready to move on to section 2. So section 2 is about finding implementations of the toObject method from the content type handler. So like predicates, classes in CodeQL can be used to encapsulate reusable portions of logic. And so we saw this in the slide deck. Classes represent single sets of values, and importantly, they can also include operations, which are known as member predicates, that are specific to that set of values. So we've seen numerous instances of this already. So we saw if statement, and then if statement.getThen, method access, and method access.getMethod, method and method.getName. One thing I didn't show you before actually was the jump to definition feature that's available in CodeQL. So if you right click on a type, you can go to definition. You can also do that using F12. And you can actually see the source code of the class that we're depending on here. And so actually all the CodeQL classes, all the standard library is actually open source. So it's all available in GitHub /CodeQL, that repository. There's a link at the bottom there. And you can actually jump to the definition here and you can see which member predicates are defined. So you can see here for method access, you see definitions of things like get an argument, get argument, the get method implementation we were looking at before. So that's often helpful when you're kind of exploring the standard libraries. So what we're going to do, the first question here, is to create a CodeQL class called content type handler to find the interface org Apache struts2 REST handler content type handler. So as a reminder, there's a template here of what a class looks like. In this case, we're going to extend the standard library type called ref type. So ref type here stands for reference type. And this is basically the set of things like classes in Java that are referred to by reference. Okay, so the question here is to write this class and to fill in the characteristic predicate here with the appropriate conditions. And remember, there's a hint down here if you get stuck. I'm going to provide 2 minutes again for these ones. If you feel like you need a little bit longer, just let us know on the Slack channel and we'll up it a bit. Okay, we'll go through the answer now. So again, the question was to write a CodeQL class called content type handler to find this particular interface. And you can use this template to fill in. So what we're going to do is we're going to write this out. So we're going to say class content type handler. So remember, classes have a name and they have to extend an existing type. In this case, we're going to extend a ref type. So this is classes, interface, type parameters, arrays, and so forth. And that would be a valid class in and of itself, but it still only represents the set of all the ref types in the program. So we need to provide a characteristic predicate that specifies what conditions make content type handlers special from the rest of the ref types. And the answer here is that they have a name which looks like this. And so if we have a look at the hint, it says use ref type.hasQualifiedName, which takes two parameters, package name and class name, to identify classes within the given package name and class name. So we've got a little example here of what that looks like. So you can say from ref type R, where r.hasQualifiedName, so has a package name and a class name, in this case Java lang string, and then you can select R. And remember, as we talked about before, within the characteristic predicate, you can use the magic variable this to refer to the ref type. Okay, so we're going to say this dot as qualified name. And what we're going to do is we're going to copy out this. You can see this is in two parts here. So it wants us to provide the package and the type name separately. And there we go. So now what we're saying here is that a content type handler is a ref type which has the qualified name org Apache struts2 rest handler content type handler. Now, it would be nice to be able to test this without having to write a new query. And in fact, we can actually do that. So we can right click either on the class or on the characteristic predicate and choose quick evaluation. So you can run quick evaluation on predicates, on classes, and on complete sets of formula. And this is a way that you can very easily start to debug and further understand your CodeQL. So we've written this class. We want to make sure it's returning the right thing before we continue on with the next part of the query. So you can see this has returned one result. It's a content type handler, and it's returned the interface content type handler. And that's what we expect, right? Because there's only one definition of this interface in the code base. So this is great. All right, so question 2. Create a CodeQL class called content type handler toObject for identifying methods called toObject on classes whose direct supertypes includes content type handler. So there's a bit of a mouthful. If you're not sure where to start, remember to go to the hint here. But if you break it down step by step, you should be able to write a query for that. To start the timer, 2 minutes. Okay, we'll go through the answer now. So if we expand out the hint here, then there's a few hints. So the first one is use method.getName to identify the name of the method. I think we've seen that before. To identify whether the method is declared on a class whose direct supertype includes content type handler, you will need to firstly identify the declaring type of the method using method.getDeclaringType. Secondly, identify the supertypes of that type using reftype.getASupertype. And thirdly, use instance of to assert that one of the supertypes is a content type handler. So what we're going to do here is we're going to write out a new class, content type handler to object. And it's going to be used for identifying methods called toObject. So we are going to extend method. We need to add a characteristic predicate. So far this is pretty much similar to the ref type one that we had above, except that we're starting off with a set of all methods. We want to refine it to only those methods that are called toObject and that are on something that implements this content type handler interface. Okay, so the first thing we're going to put in is that this.getName equals toObject. Then the second part that we're going to put in is this aspect here. So firstly, well, we need to know what type this method was declared on. So we can say this get declaring type gets the type in which this member is declared. Now, having got the member type, what we want to know is whether that member type, so the type that this method is declared in, we want to know whether it extends content type handler, because not all the methods named toObject in the program may be on things that extend content type handler. So the way we're going to do that is to say get a supertype. And now what we want to say is that supertype includes, or the set of supertypes here includes the content type handler interface. So the way we can do that, well, we actually saw this earlier on a few times. We can actually say instance of, and then the content type handler. So just checking in, Arthur, any questions on the Slack channel we should report back?
Just one came in. Is there any preference between get name equals a string or has name with a string argument?
No, I mean, I think that's just more personal preference than anything else. So I think the question here, to clarify, is you can also do this the same way with a toObject like this. No, there's really no preference. I mean, under the hood, these are both predicates. So this one is a predicate that has a return type, a result type. This one is one that takes a parameter. Under the hood, it's calculating the same thing. It's not really, it's more about kind of personal preference as to what makes more sense in terms of the, or what reads better to you. For simplicity, I've been using the same one all the way through. So I've been making sure I use this .getName equals. So I'll continue to do that, but you're entirely free to use hasName as well.
Thank you. I don't see there's any questions at all. There's other people are typing. So would you like to wait a sec or? Let me see.
Yeah, let's give it a few seconds and see whether anything else comes through.
There was also a question earlier. Maybe I can just. Is it possible to analyze dependencies as dependencies to identify code, all code that has a specific dependency, things like that?
Yes, so we do this for some of our languages. So there are kind of two ways that we can look at dependency. So as I said before, for compiled languages like C# or Java, when you compile the code, you have to provide a reference to the libraries that you're actually compiling against. And so when we see that compilation to kind of populate our database of facts about the program, we observe that compilation, we look at the arguments to the compiler, and we see that you've passed in these particular dependencies. And so when we build our database of facts, we store a reference to the fact that you depend on these particular binaries. Now, it's not always a straightforward process to go back from those binaries to find out what particular version they were. It's possible for some languages. For other languages like JavaScript or Python, we depend a little bit more on package references in the repository itself. So in those cases, we can actually build those kind of package references into the database itself, and we can potentially query those as well. Now, this is kind of an interesting question because it sort of hits on the vulnerable dependencies topic. And so GitHub actually has a native feature that looks for vulnerable dependencies in your source code. It doesn't use CodeQL. It's just looking at your definitions, things like your Maven POM files or your packages for Python, or your npm, your modules dependencies for JavaScript. And that's sort of a lightweight solution. What that can do then is match that against a database of known vulnerabilities for different library versions, and it reports that within GitHub itself. So that's a feature that's already in GitHub. You can already use that today, both on open source code and private code as well. Now, the value that CodeQL can bring on top of that is slightly different. So as I said, you can have the kind of dependencies in the database. What CodeQL can also bring is a knowledge of which aspects of those libraries you use. So one problem with the sort of typical vulnerable dependency analysis today is it will say, you're depending on a vulnerable version of library X, but we don't know if you're using it in a way that actually makes you vulnerable. So for example, if there's just one API called in this library you're using that is known to be vulnerable, that's why, say, a CVE was raised on it. The kind of vulnerable dependency analysis that doesn't use CodeQL doesn't know that. So one interesting aspect here is whether you can use CodeQL to help identify unsafe uses of vulnerable libraries. And there are actually a couple of examples of public queries we have that use that. So I think the JavaScript prototype pollution query, if you want to look that up afterwards, is an example where we look at both the dependencies of your code and what your source code does with that dependency in order to find whether you're using it in an exploitable way. That's another good question there.
Thank you. Another question that came in when you started talking. So the CodeQL CLI database creation, does it requires buildable code, or would like partial code also work?
Yeah, so it requires buildable code, and one reason for this is because for compiled languages, it's generally better to observe what the typical build does for that project. And what we do actually, in fact, is you provide us with a build command. We run your regular build, and we just watch out for whenever the compiler is called. And every time the compiler is called, we effectively mimic what the compiler does to populate our database of facts. Now, the reason that we do this is because for compiled languages, it is often important for accuracy to actually see what the build does. And so there are numerous examples of the build generating files as it goes along, which help tie the project together. Builds using multiple different versions of dependencies, so you don't know which version is going to be used until the build actually occurs. These kind of aspects are only really revealed kind of when you observe a build. And so for that reason, for buildable languages, we want a build command in order to be able to do it. Unfortunately, this means that we can't build partial projects. So if you can compile something, then we can build it. So if you can, say, compile one component of a project, then you can build a database for it. But if you can't compile it, then yeah, unfortunately, you can't build a database for those ones. And I should note as well, this is particularly important it's quite important for Java and C#. It's very important for C and C++. like it is extremely difficult to do any kind of sensible source code analysis on C and C++ without running a build, because C and C++ files often use the preprocessor, which effectively arbitrarily rewrites the files at build time. And so for C and C++, you know, it's absolutely critical that you have a build in place in order to get an accurate picture of how the project fits together. Well, that's another good question, so thank you.
You're welcome. Another question is, are there any plans for supporting functional languages such as Clojure or other languages that target a JVM, I guess?
Yeah, so at the moment we don't have any other languages on the roadmap. But you know, we are sort of continually evaluating the kind of set of languages that we support. And the sort of considerations there are typically popularity of the language, also the rate and change of the popularity of the language. You know, is the language becoming more popular or less popular? And also, obviously, commercial decisions as well as to kind of what our customers are interested in. And so this is definitely an area that we value feedback from the community. So if there are particular languages you'd like to see us support, let us know. And we kind of feed that into the decision-making process as well. Thanks.
Thanks. One question is the QL language, is it open source?
So the language itself is not open source. So there's so I should say there's a language specification that we publish openly. The implementation of the language, the compiler, and in particular the query optimization engine, that is all closed source. The aspect which is open source is all the queries themselves. So the queries themselves for all of our languages are open source. They're in the GitHub CodeQL repository. And part of the reason that we do that, so the motivation here really is that we think the way to you know, best help the world secure their code is through community-powered security. And so one of our motivations here is to really allow security researchers, and I'm sure there are many security researchers on this call, who have, you know, deep technical knowledge of finding security vulnerabilities, to be able to encode at least some of that knowledge as these queries, and then to be able to share them with the community via open sourcing of the queries. And we think that over time, this is going to become an extremely effective way to really quickly deal with new and emerging security vulnerabilities. So, I mean, we had a good example of this through one of our customers, actually, Microsoft. So a couple of years ago, you might remember the zip slip vulnerability that was, well, at least labeled by SNCC, and they found a bunch of cases in open source software. And at the time, and still at the moment, Microsoft was one of our biggest customers and one of our biggest users of CodeQL. And they saw this zip slip vulnerability, which is essentially a tainted path vulnerability. And they saw that revealed. And the very next day, in about 20 minutes, they wrote a query to find instances of zip slip in C# code. And the day after that, they had then run it on dozens of their kind of largest code bases. And the month after that, they then released the query to be open sourced. And so there's a kind of a nice pattern here of firstly being able to rapidly identify new and emerging security vulnerabilities, and secondly contributing those checks back to the community so that everybody benefits from them. All right, thanks. Okay, let's move on to the next question or the next exercise on here, and we can come back to more questions later on in the process. All right, so question 3 here. 2 object methods should consider the first parameter as untrusted input. Write a query to find the first, i.e. index 0 parameter for 2 object methods. And so the way I suggest you do this, if you've been kind of following along what I've been doing, is let's just comment out this query for now and write your new query underneath here. And I'll stop the timer for 2 minutes. Okay, let's go through the answer here. So as a reminder, the question, two object methods should consider the first parameter as untrusted user input. And so we just want to write a query to find the first parameter for two object methods. So if we look at the hints, it says use method.getParameter to get the ith index parameter and create a query with a single CodeQL variable of type content type handler to object. So let's do that. We're going to call this variable two object method, and we're going to select the two object method and two object method dot get parameter. We want the 0th parameter. So this is going to return the places in the program, the parameters in the program that we think are taking in untrusted user input. And we can see that there are 8 of them here. So this is the 8 implementations here in this version of Apache struts that implement the two object method. So you can see here we have like HTML handler, implements two object method, there's empty, JSON lib handler. So this is obviously doing some JSON processing. We have multi-part form, which doesn't do any handling of two objects, Xstream, which is handling XML, and a couple of test ones here as well. So we seem to be picking up the right things. And again, if we have a look at what's happening here, let's look at the JSON one. The second column here is representing the parameter that we think is taking in untrusted user input. Cool. All right, so that's the end of section 2. Are there any more questions that we want to cover before moving on to section 3? I'll assume not if Arthur isn't unmuting, so let's move on. All right, so section 3, unsafe XML deserialization. So we've now identified places in the program that receive the untrusted data and the places in the program that perform potentially unsafe XML deserialization. What we want to do is really combine those together now and ask the question, does this untrusted data ever flow to the potentially unsafe XML deserialization call? Now in program analysis, we typically call this a data flow problem. Data flow helps us answer questions like, does this expression ever hold a value that originates from a particular other place in the program? Now, the way to think about data flow problems is to visualize them as one of finding paths through a directed graph. And this directed graph has nodes, which are elements in the program, and edges that represent the flow of data between those elements in the program. And then once you have this graph, if a path exists in this graph, then data flows between those two nodes. So I've got a little example here. I'll just maximize this. So consider this example Java method. So it's a function, it returns an integer, and it takes a parameter that we've called tainted, and it's an integer. And you can see that this value effectively propagates through this method in different ways. So firstly, this parameter is accessed. The tainted parameter is accessed and stored in X. And depending on this value of some condition, X is either restored in a variable called Y and then used in a call foo, or X is just returned. And in this final case, we return -1. Now, if we want to think about what the data flow graph of this method will look like, well, it'll be something like this. So we will have a data flow node that represents the parameter, and that's going to be called tainted. So this represents this piece of source code here. And we also have a data flow node representing the access of that parameter here, which is going to be an expression. This is a parameter access expression. And as you can see from the graph, we have a dependency between them, a flow between them. And so there is a node for this element, a node for this element, and an edge between those two elements to show that data flows between the two. Now, of course, this parameter is restored in the variable X. And then X is then used in one of two ways. Either it's used to reassign to Y, or it's used in this return call here. Well, what does that mean from the data flow graph? Well, it means there is going to be two nodes in the data flow graph. One to represent the access of the X here, and one to represent the axis of the X there. Now we can see this is represented by these two nodes here. They both have edges from this tainted access here, because data flows from here to both of these cases. And then finally, this X is restored in variable Y, and it's accessed in call foo, in the argument to call foo, which we know is an expression. And so there's another expression node here, Y, to represent this bit of the program that again has data flow from this assignment of X into the variable Y here. So this is the data flow graph that we'll be analyzing for something like this. And so the thing to bear in mind here is that this is all about flow through this graph. If there's a path through this graph from, say, tainted to Y here, then data flows between the two. Now, CodeQL for Java provides data flow analysis as part of its standard library. So you can import it using SAML code Java dataflow. And the library models nodes using the dataflow node CodeQL class. Now, this dataflow graph is separate and distinct from the AST that we talked about before. So you'll have effectively in the database one tree that represents the basic structure of the program. And the dataflow nodes are a separate representation. And the reason for this is we want to provide some flexibility in how data flow is modeled. So we don't want to be tied to only having data flow nodes for things that appear in the AST. And so there are a small number of data flow node types. So the ones that are most common, the ones we saw above, are the expression nodes and the parameter nodes. But there are other types as well, so things like definitions and so forth. So in this section, what we'll do is we will create a data flow query by populating this particular template to find flow from the untrusted user input to this XML deserialization. Now what I'm actually going to do is I'm going to actually write out this data flow template from scratch in my query here to explain kind of what each of these features are. For you, feel free to copy the template from the Markdown file once we've finished going through the explanation. All right, so the first thing we're going to do is add a new import to our query. Import seml.code.java.dataflow.dataflow. And this imports the dataflow library so that we can use it. Now, the way this dataflow library actually works, I'm just going to comment this out for now, is that you have to define what we call a dataflow configuration. Now, the dataflow configuration specifies what the sources are for this dataflow problem and what the sinks are. In other words, what are the things that we want to find flow from and flow to? Now, the reason that we have a configuration for this is because what we're doing here is global data flow or inter-procedural data flow. So we're looking across the whole program as we see it in the database, and we're actually finding flow across method boundaries, across file boundaries, across the whole program. Now, because of the scale of this, it's not possible up front to kind of build a table saying this is how data flows from every node in the program to every other node in the program. So when we're defining a configuration here, is to specify the conditions that make up the source and the sink so that we can calculate this data flow on a more restricted set of data. Now we actually have a counterpoint to this global data flow called local data flow, and that we can actually compute for the whole program because we just restrict it to the data flow dependencies within a single method. And that doesn't need a configuration. That has a simple predicate that you could call that says, is there local flow between X and Y, for example? Okay, so what we're going to do for this particular problem is define a configuration. We're going to call it struts unsafe deserialization config. And it's going to extend this library class called dataflow configuration. So we should note that this is a special kind of CodeQL class. We call it a configuration class. And its purpose is slightly different to the classes that we've seen before. So it's actually designed as a wrapper, a container for a series of related predicates. So in this case, a predicate for defining sources and a predicate for defining sinks. By defining this within a single class, it means that we can tie the source and sink definitions together. Now, the way these configuration classes work is that at the moment they extend string. And so you have to define a unique string in the characteristic predicate for this particular configuration. So let's copy out the name here, specify that there. Specify a single line here. Okay, so we have a name for this now. Now there's actually two predicates that we need to implement to specify what the sources and sinks are. If we actually jump to definition on the configuration, we can see what they are. So we want a isSource predicate and an isSync predicate. So let's copy those out. Let's paste them into here. They're abstract because they're things that we need to implement. So we're going to specify that these are overriding predicates. Right. We're also going to qualify this reference. Data flow node. Okay, and so what we're going to need to do is to fill this in order to specify what the sources for our problem is, and we're going to need to fill this in order to specify what the sinks for our problem are. So this is going to be our first question when we get to the questions here. Before we do that, I want to show you what this actually looks like in a query. So the way this works in a query is you specify the configuration you're interested in. For now, we can stub out these. So you'll notice this is complaining because we haven't got any conditions in the body here. Now, if we don't want to apply any conditions at all, we can actually use a shortcut of none. So let's just do that for now so that we can compile the program. Now we can see struts unsafe deserialization config appears in the autocomplete. We're going to use that. And then typically you're going to select the configuration you're interested in, and you're going to have a variable for each of the source and sink. And in the where, you're going to say config.hasFlow source sink. So this is applying a logical condition. So this is part of this particular configuration. Yeah, this is part of the particular configuration. And the flow, this will effectively calculate a table of sources and sinks. So these are things that adhere to the source and sink predicates above, which are connected directly or indirectly by data flow. Okay, we're going to say select config sink. And we are going to specify a message here. So we're going to say has struts. Sorry, put the message up here. So unsafe deserialization XML. Okay, and then this is the template here. Okay, so the final two questions here, and we will do them do them both together here. So is to complete the isSource and isSync predicates using the queries that you wrote for section 2 and section 1. So I will just start the timer there. Okay. So let's go through the is source. So the hint here is that you can translate from a query clause to a predicate by converting the variable declarations in the from part to the variable declarations of an exist, placing the where clause conditions, if any, in the body of the exists, and adding a condition which equates the select to one of the parameters of the predicate. And remember to include the content type handler to object class you defined earlier. So we've still got the predicates and classes we defined earlier here. And what we're going to do is we're going to take this query that we wrote before, and we're going to put it into the is source predicate here. Right, so as it says, the way that we convert this is to say, change the from to an exists. So exists content type handler to object. It says to place the where clause conditions, if any, in the body of the exists, where we don't have any where clause conditions for this one. And to add a condition which equates the select to one of the parameters of the predicate. So what we're going to say is that the source is equal to the toObject method, get parameter 0. Now we can't actually say that directly because, as I mentioned before, data flow nodes are not the same as AST nodes. So you can see here, this is even highlighted here, node is incompatible with parameter. Now, the way this actually works is that data flow nodes have a converter on them, which allows you to get the equivalent AST node for your data flow node. In this case, this is called as parameter. Okay, now we have the source defined. What we'll do is just give you one more minute to complete the isSync. And then we'll go through the isSync. Okay, let's go for through the sync answer then. So the hint here is just to complete the same process as above. So again, let's copy this query in. What we're going to do is, as before, we're going to convert this to an exists. So we're going to say exists expression arg. As it said above, let's just expand the hint out above. We're going to convert the where clause just to a condition in the body of the exists. And we're going to assign a parameter of the predicate to the select. So in this case, so before we used as parameter because it was a parameter. In this case, it's actually an expression that we're interested in here because the argument to the from XML call is an expression. So we say sync as expression equals arg and save that here. Okay, so what we can do at this point, so we now actually have a completed query that we could use. What we can do at this point just to validate that we have the right things is we can click on these is source and is sync predicates, run this query, and we can just validate that we have the results that we expect. So here we can see those 8 in parameters. Run here. And we should have the 2 parameters here that are are in the from XML. Sorry, the 2 arguments to from XML. And now if we run this query, we should actually be able to find the sync of the unsafe XML deserialization. You can see we've got 1 result. And actually, if we click into this, this is in fact the CVE that our colleagues in the GitHub Security Lab team actually reported. So it's taking untrusted user input in as the reader in, and it's passing it straight to this xstream.fromXML. And it's doing nothing to protect this in any way. So xstream itself has some options that you can set before calling from XML to prevent sort of arbitrary deserialization. Well, none of that's actually used here at all. And so this allowed actually arbitrary remote code execution. Now, in this case, it's kind of easy to verify that this is a true positive, an interesting case. Because the parameter and the which is the source and the argument, which is the sync, are both in the same method. Now, this is often not the case for security vulnerabilities. Often they are spread out across the program, and there may be dozens of steps that go from the source to the sync. So, how can we improve our query to actually report that? So, the very final part of this workshop is going to be converting this to what we call a path problem query. Now, there are 5 parts to converting a query to a path problem query. So the first is converting the @kind from problem to path problem. So queries, and I think we've seen this on 1 or 2 occasions already, can have some metadata at the top. And one of the pieces of metadata is a kind, which can be a problem, which can be a problem or path problem. So for a problem query, we'll get just the result that we saw before, with slightly improved formatting. And you can see we get this this 1 result. What we want to do is to convert this @kind to from problem to path problem. And this tells the CodeQL toolchain to interpret the results of this query as path results. The second thing that we'll need to do is add a new import dataflow path graph, which will report path data alongside the query results. The third thing we'll need to do is change the source and sync variables from dataflow node to dataflow path node to ensure the nodes retain path information. And then the 4th step will be use has flow path instead of has flow. And the 5th step is to change the select to report the source and sync as the 2nd and 3rd columns. The toolchain combines this data with the path information from the import of path graph to build the paths. So we are close to running out of time here. So I'm going to leave this as an exercise you can complete on your own. The solution is available here under the expansion. So we have a bit more information at the bottom here. So if you want to find out a bit more about how this vulnerability was originally identified, there's actually a blog post on the GitHub Security Lab page that explains how we found it. And although today we have created a query from scratch to find this problem, it can actually also be found with one of our default security queries, such as unsafe deserialization.ql. You can actually see this working on a vulnerable copy of Apache struts. So this is the one that we actually built the database from. So you can see the clone of this on GitHub here. And it's been analyzed on lgtm.com, which is our free open source analysis platform. So if you click on this link here, it will take you to the result in Xstream Handler on the actual vulnerable version of the code, as found by the out-of-the-box query. Now, there's a wealth of information that you can move on to after this. So there's a few tutorials available for Java. In particular, the one on analyzing data flow is probably an interesting one to follow up next with after this. We actually have full CodeQL training courses for Java available for free online. They're all in the format of a slide deck that you can follow through with. You can also, as I mentioned at the start, enter the CodeQL Java Capture the Flag challenge that we've launched for Satellite. That's on the GitHub Security Lab website. And you have a chance to win a prize. So you can put your newfound CodeQL, Java CodeQL skills to use. We also have some older capture the flag challenges there as well. We have ones for C and C++ or for JavaScript that you can try out. No prizes for those ones anymore. They've finished, but they're good for learning anyway. We also have a CodeQL course on GitHub Learning Lab. If you want to find out more about how you can find vulnerabilities using CodeQL, then the GitHub Security Lab research blog is a really good place for security researchers to go to understand how the GitHub Security Lab actually uses CodeQL on a daily basis to find new and interesting security vulnerabilities. And of course, as I've mentioned numerous times already, all of the CodeQL queries and all the libraries are open source. So you can click this link and visit those. And just as importantly, if you write a new query and you want to contribute it back to the community, you can do that as well. And we have a contributing guide here that you can follow to do that. Yeah, and so thank you very much for listening. I don't think we quite have time to answer any more questions on the audio channel, but we'll be on the Slack channel for a bit longer yet. So if you have any burning questions, please please answer them there, and we'll all be there to be able to answer your questions. So thank you very much for turning up. Thank you very much to my helpers and to the team that set this all up. Yeah, hopefully talk to you soon about CodeQL. Thanks.